Okay, redox reactions then. I'm sure you've seen this acronym before, oil rig. So oxidation is loss of electrons, reduction is gain of electrons. So if a species is losing electrons, it's being oxidized. If it's gaining electrons, it's being reduced. There's two more definitions that you may not be so aware of, and that's these two: oxidizing agent and reducing agent. So you've got to think about it. What is that thing doing? Okay, if it's being reduced, so if it accepts electrons, it gains electrons, it must be oxidizing something else. So the thing that gets reduced in a reaction is the oxidizing agent, and vice versa. The thing that gets oxidized loses electrons by giving them to something else. So it's reducing something. So it's a reducing agent. Okay, so these are two definitions you need to know. So in any reaction that's there's oxidation, there's always going to be reduction as well. They go together, oil rig. The substance that gets reduced is the oxidizing agent, because by being reduced, it oxidizes something else. The substance that gets oxidized is the reducing agent, because by losing electrons, they're not just disappearing, they're going to another substance and they're reducing another substance. So the substance that gets oxidized is the reducing agent. So if we have a look at an example, we can follow this using our oxidation numbers. So here's a reaction: sodium bromide, chlorine water makes sodium chloride and bromine. So always do the easy ones first. You've got to try and pick out things that are changing. Group 1 in a compound is always +1. So it's +1 there, it's +1 there. I'm not going to bother doing that. But elements by themselves, Cl2 is a bond to itself, so its oxidation number is 0. And then bromine, its oxidation number is 0. So bromide over here though is not 0. That's +1 for sodium. The bromine must be -1. The chlorine over here, again the sodium is +1. The chloride is -1. So if we have a look, we got the bromide Br in NaBr was -1 and it's gone to 0. Okay, that means that it's gone from being negative to neutral. So remember that electrons are negative, it's lost electrons. Okay, so it has been oxidized. It's gone from -1 to 0. So the Br in NaBr is oxidized. If we look at the chlorine, Cl in Cl2, it starts off as 0 and it ends up as -1. So it's got more negative. So to be able to get the oxidation number, or the oxidation state, I should say, to get more negative, it must have gained an electron. Okay, so the Cl in Cl2 is reduced. So if you think then of the oxidizing agent, it's not the thing that's being oxidized, it's the thing that causes the oxidation. So it's going to be the thing that got reduced. So the oxidizing agent is Cl2. It caused the Br and NaBr to be oxidized. The reducing agent is the species which has been oxidized. Now, I'm not just going to say Br, because Br by itself wouldn't do anything. It's Br in the form of NaBr. Okay? The reducing agent is NaBr. Even though the Na didn't change, the sodium ion needs to be there for it to be Br- in this case. So the reducing agent, the thing that you'd use in this reaction to cause the reduction of the chlorine, is NaBr. So these are always flipped. The thing that is oxidized is the reducing agent. The species which is reduced is the oxidizing agent. Let's look at another example. Okay, so going to assign oxidation numbers. Keep your eyes out for things that are changing. Look out for elements. The biggest mistake we call is +2, but it's not +2, is it? It's 0 because it's an element. The hydrogen is an elemental form, 0. Okay. Hydrogen over here, doesn't matter there's a big 2 here, this makes no difference. This just means there's 2 HCl. This is what's happening in each HCl that matters. The hydrogen is +1, the chlorine is -1. Okay. Group 2 element I should say in a compound is +2. And it's what each chlorine is here. Each chlorine is -1. So, let's look at the magnesium first. Mg has gone from 0 to +2. Okay? It's lost 2 electrons. Therefore, Mg is oxidized. If something is oxidized, it's the reducing agent. What else is changing? The chlorine is -1 on both sides, we can ignore that. Okay, it's not -2 here, it's what each chlorine is, that's important. The hydrogen's gone from +1 to 0. So H in HCl has gone from +1 to 0. That's getting more negative. It's gained 1 electron. Each hydrogen has gained 1 electron. So gain of electron is reduction. So H in HCl is reduced. And if it's reduced, that means that it is the oxidizing agent. So HCl is the oxidizing agent. Okay, let's do one more. So here we've got sodium reacting with sulfuric acid. So again, I ignore all the big balance numbers, they're irrelevant to oxidation numbers. Each sodium is 0. Hydrogen over here is 0. Well, I always do those ones first because they're the ones where people make mistakes. Okay, now, there's a long way. I can work out every oxidation number here in sulfate, but it's SO42- here, it's SO42- over here. It's not changing, it's a spectator ion. But I can see there's each hydrogen here must be +1, because if all of that is -2, you have to have 2 lots of +1 to make it 0. And the same over here, the sodium must be 2 lots of +1. Okay? So, if we go from the sodium, start from sodium first, Na starts off at 0 and it ends up, each Na ends up +1. It's got more positive, it's lost electrons. So each sodium has lost 1 electron. If you look at the hydrogen, it's gone from +1 to 0. Okay, so +1 to 0, each hydrogen has gained 1 electron. So oil rig oxidation is loss of electrons. So Na is oxidized. That means it's the reducing agent. Hydrogen in H2SO4 is gained, so rig reduction is gain, so it's reduced. So if it's reduced, it means it's the oxidizing agent.